We're moving on to section 4.5. We're going to look at 2 by 2 matrices and the special things that we can do with those. So it's only going to be matrices of the size 2 rows by 2 columns today. Look, we have a 2 by 2 matrix here, 2 rows, 2 columns. I want to tell you what a 0 matrix is. So I'm really just going to explain 3 new terms to you and a little bit about their use. All right, imagine multiplying this 2 by 2 matrix by a matrix that has only zeros. It's also a 2 by 2 matrix, so we can totally multiply those together, right? Let's look at what the answer for this would be. It's going to be a 2 by 2 matrix, right? First row. Oh goodness, making terrible mistakes here. First row, first column. 2 times 0 is 0, 3 times 0 is 0, 0 plus 0 is 0. Second row, first column. Is 0, this times that is 0, added together is 0. Moving to the second column, first row. 2 times 0 is nothing, 3 times 0 is nothing, nothing and nothing is nothing. And as you probably are expecting, this will also come out to be 0. This matrix here has a use and it has a name. It's called a 0 matrix. It's a matrix that has only zeros, and what it does to another matrix is when you multiply them, it gives you a matrix where everything is just 0. And later on in this week, hopefully, you'll find out about this 0 matrix's use. One cool thing about the 0 matrix is that, remember how we said if we have 2 matrices, matrix A and a matrix B, matrix A multiplied by matrix B is not the same thing necessarily as matrix B times matrix A. In this case, when one of the matrices is a 0 matrix, we can switch the 0 matrix and the other matrix. So some matrix, let's call it A, multiplied by a 0 matrix is a 0 matrix. But if we switch these matrices, the 0 matrix times this other matrix, you can check to see if I'm right, but I am. That also comes out to be a 0 matrix. So with the 0 matrix, this boundary really that we have in multiplying matrices, it doesn't apply. Okay. That's all I want to say about the 0 matrix. Now, there's another special type of matrix called the identity matrix. Let's say we want to multiply this 2 by 2 matrix by another matrix, and we want our end result to be our original matrix. What do we multiply it with in order to get our original matrix of 2, -4, 3, 1? What do we multiply it with to get our original matrix? Well, there's one special matrix for that, and it's called the identity matrix. It has ones in this diagonal, zeros there. It's called the identity matrix. Because when you multiply any, well, this is for 2 by 2s, if you multiply a matrix by the identity matrix, the original matrix keeps its identity, right? It stays the same. That's why we call it an identity matrix. Let's see if this is even true, because I just wrote that it's true, but maybe you don't trust me. First row, first column, 2 times 1 is 2. 3 times 0 is 0. 2 plus 0 is 2. Second row, first column, minus 4 times 1 is minus 4. 1 times 0 is nothing, so minus 4. Second column, first row, 2 times 0 is 0. 3 times 1 is 3. 0 and 3 is 3. Second row, second column, negative 4 times 0 is 0. 1 times 1 is 1. 1. There we go. And again, like I said with the zero matrix, we said this rule about the order in which we multiply one matrix by the other doesn't apply when you multiply with a zero matrix. Same is true for this identity matrix. If we switch these two and we say we're going to do 1, 0, 0, 1, the identity matrix, and multiply it by 2, negative 4, multiply 3, 1, our answer is still going to be the matrix that is not the identity matrix, right? So the outcome is the same. So here with the identity matrix, you are allowed to switch the order of the matrices. Okay, so far we have zero matrix, we have the identity matrix. Now I want to tell you how to find the determinant of a matrix. And in the next lesson, you will use the determinant to find out new information. For now, I only want to tell you that it's called the determinant and how to find it. All right, if this is our matrix that we start with, see how there's just letters instead of numbers, but if this is a matrix A, it has the values A, C, B, D, then the determinant of the matrix, which we write like this, and we don't want to confuse this with absolute value. This is, well, this we call the determinant, right? It's defined as follows. So we get a little formula here. The determinant of A, the determinant of matrix A, equals A times D, which is A times D minus, oh, I want to do purple because I want to circle them, B times C, B times C. So let me give you an example. If we had the matrix, again, we're only talking about 2 by 2s, right? If this is our matrix, then, so A, then the determinant of A equals this term times this term, 1 times 4, 4, minus B times C, minus these two multiplied. 2 times 3 is 6, so minus 6. And the determinant is negative 2. Yeah? I can do another one if you want. If we had matrix B and it's 6, 5, 2, 1, then the determinant of B equals A times D, which is these two multiplied. 6 times 1 is 6, minus these two multiplied, 5 times 2, so minus 10, whoops, 6 minus 10 is negative 4. That's how you find a determinant.